Welcome to the Electrical Hazard Boundaries webinar, and today we're going to be talking about how to be in compliance with OSHA and 70E in regards to those electric shock and arc flash boundary requirements, understanding what that means, how to establish them, how to work within them, how to keep other people out of those boundaries, such and so forth. So my name is Caitlyn Wininger, and I have my CESCP, which is Certified Electrical Safety Compliance Professional through the NFPA, which basically just means that I know the NFPA 70E. Okay. Started out as an engineer, been working with HRSG for several years now, but I'm excited to talk about this important topic today.
I'm Trey Toliver. I've got my level 1 through 4 certs in industrial electric. Started the HRSG about 4 years ago doing the office side of things. Moved out to the field, doing field work, a little bit of both. Really my main goal though is to keep everybody safe, make sure everybody returns home safely at the end of each day.
It's a pretty good goal. Yeah. All right, so let's open it up with a couple poll questions to get us started. So first off, let's see, do you have electric shock and arc flash hazard labels applied to your equipment? So these are going to be what tell you how far out the boundaries are, essentially. So let's see. You should be able to click yes, no, some do, some don't. Maybe some's labeled, but some's not. Or not sure. Maybe you just haven't really looked, don't really know much about that. So there should be a poll popping up for you. Select which one and click the submit button.
We do here. We got labels on our equipment.
Yes, we got that covered. Pretty easy to get that one done.
Yeah. Yeah.
Whenever you got all those resources right in-house.
Yeah.
It's super simple.
A lot of some do, some don't in there.
Yeah.
From what I can see.
Actually, a good number saying yes, that you got those labels, which is awesome. Well, that's the starting place for all this stuff, honestly.
I think we'll cover too, and making sure those labels have the proper information on them too. And
yeah,
some answers might change, honestly.
Yeah, that's true. Okay, we'll give it just a few more moments. We got about 80% of you voted so far, have submitted your response. Thank you for participating in that. See if anyone else wants to jump in here. Okay, go ahead and close the poll. Let's show the results. So we got the majority saying yes, that you have those labels, which again, that's awesome. For those of you who said that you don't have any of them, that's kind of your first step, is making sure that you have an analysis performed so that you know what those boundaries are. We're going to get into all that later. And then some do and some don't. Well, okay, maybe not all electrical enclosures have to have both. If it's a certain threshold, you don't have to have the shock, or I'm sorry, have to have the arc flash labeled, but definitely shock labels no matter what. Even if it's 24-volt controls, you should probably know what's in there before you access it, just to be sure. And for those of you who say not sure, we'll go out next time you're walking around your facility, just take a look. It's pretty clear whether they're on there or not, and we'll show you what those can look like. All right, so let's get back to this second poll. Do your qualified workers establish the electrical hazard boundaries prior to accessing equipment? Okay, so that's what we're talking about today. If you don't really know what that means, you can click not sure. Maybe they do sometimes, but not always. It depends on what they're doing or what equipment it is. Maybe they do it all the time. Maybe don't do it at all. I don't know. Let's see what the results are. So do your qualified workers establish electrical hazard boundaries prior to accessing equipment? Yes, no, sometimes.
If you got those labels, are you using them?
Basically, that's what I'm asking.
Are we using the labels how they should be used,
right,
and the information that's on them?
Right. I've been given a lot of trainings recently, and it's interesting because most of the guys and gals that I'm talking to, they're like, yeah, we have those labels. I think we've had that study done, and keep it updated and all that stuff. And I'm like, okay, great. Have you ever read through them? They're like, oh, have you ever used the information on it? Well, no.
Yeah.
Like, okay, so what was the point of getting the study done then, right? Oh man,
it's a foreign language.
Yeah, sometimes. And I get it, that's a lot of information to digest, but any qualified person should know how to do that. All right, so we got the majority voting here. Share results. Oh, there we go. Okay, so even though the majority have the labels, not the majority said that yes, you always establish those boundaries. Okay, so sometimes it depends. I could see where There might be some unique situations where that isn't necessary, but it's going to be pretty rare whenever we dive into this that you can truly get away without needing to establish those boundaries prior to accessing equipment. All right, so let's see. We've got 3 main sections that we're covering today, and then we'll wrap up with questions and discussions. But again, if you want to go ahead and participate during the webinar, use that question feature. I'll be kind of monitoring it off to the side here to make sure that, if it's an applicable question for the topic we're currently talking about, let's go ahead and get it taken care of, right? All right, so we're going to start out with understanding the electrical hazards and then going into what those boundaries for the electrical hazards are, who needs to be worried about them, when, where, how, and why, right? All the wonderful questions. And then we'll kind of wrap up with how to make sure that those electrical hazards and those boundaries associated with them have an established policy and work practice in your workplace. Okay, so let's dive in. What are the electrical hazards we're worried about today? You want to talk about this?
Yeah, electric shock and electric burn, as are going to be our 2 main topics. The pie chart you guys see, it's a total number of non-fatal electrical injuries in the private industry. Okay, these are recorded injuries.
Right.
I always like to make a big point of that. How many times do we get shocked or hurt? It's not worth the paperwork with the safety department. Okay, electric shock.
Don't take that attitude, but that's the reality of what happens, yeah.
Yes, electric shock, though, is the majority.
Yeah.
Electric shock happens more than anything. It's what we come across. It happens every day. People are getting shocked.
Yeah.
And so that's kind of what we're going over today, is keeping people from being a part of this chart.
Right. So it's both shock and burn, though, right?
Here's our total number of fatal electrical injuries, from 2003 to 2021. Okay, we can see the curve. It's got a decline a little bit, kind of plateaus there from 2016, 2021, little jumps here and there, right? Far superior than what it was in 2004 to 2006, where you're just over, the 250 number. Obviously in 2021, though, with 152 deaths, that's 152 too many.
Right, absolutely. Right. Yeah, whenever I look at the stories behind some of these statistics, at least the ones that I can find, because they're not always readily accessible, it adds a whole new layer of tragedy to this, because the majority, and honestly, I haven't found one truly yet, I would consider an accident. So the majority were preventable, right? Yeah. Somebody somewhere had either a gap in knowledge or safe work practice, or just got complacent and absolutely should have been prevented, right? So we want to keep people from getting killed by these electrical hazards, which is why it's so important to understand these boundary requirements and what to do within them. Okay, so there's 3 main action leading to these fatalities. And lockout tagout procedure failure or safety controls removed, that's obviously a common issue. It's always cited in the top 10, oftentimes top 5 of OSHA's, top cited violations. Contact with overhead power lines still kills a ton of people, way too many, right? Not just in the workplace, but just in general as well. But the one that we're really going to be focusing on is working on or near energized conductors or circuit parts. Okay, so not just whenever you're touching the components.
Yeah.
Within a certain distance around exposed parts, it can be reasonably assumed that you could get hurt or killed. You don't have to physically touch it for it to hurt you or kill you. Yep. Okay, so that's the point that we're making here. A lot of people try to skip the boundary setup because they're like, well, I'm not going to adjust anything while it's energized. I'm just going to take a quick look. I'm just going to, any of those scenarios where you can say, I was just going to fill in the blank. And then they skip the boundaries, right? They don't pay attention to them. Well, I'm not servicing it, so I don't need PPE. I don't need to, whatever. Doesn't matter, all right? That is still working near it. You're exposed to it. Let's protect from it.
Caitlyn, there's 3 things I'd say electricians face on a day-to-day basis.
Sure.
Typical job task. Okay, you have electric shock, arc flash, and arc blast. Those are the 3 main hazards electricians will face. The first one, the main one we're going to cover right now, is going to be shock, electric shock. Okay, there's 3 different types of potentials when we're talking electric shock. You have a touch step potential, a step potential, a touch potential. Right. Yeah, obviously, the ones going through the heart are going to be our most fatal injuries. Okay, life-threatening. Step potential as well. Okay, step potential can still reach the heart, vital organs. Another key point with these potentials, it's not always just hand in hand or hand to foot contact.
Right.
It could be shoulder to hip or shoulder to foot, foot to head, you know, depending on how you come in contact with that electricity, where the electricity flows through your body.
One of the most common ones is somewhere either your hand or along your arm and your knee. Because people have rated shoes, right? All right. As soon as you take a knee, though, that's completely defeating the protection of it. Okay. So yeah, don't want to have current passing through your body at all, because even a tiny bit can do a lot of damage, right?
Yeah. Yeah, you take, you know, 480 volts and, you know, a palm touch or something, for instance. Heart clamps tight. If you did the math here, you use Ohm's law, you know, heart clamps tight. That 10 to 40 milliamps. You know, that's a let go threshold where you're locked on.
Right. That's the point where you have to have a second person to get you off the circuit, if you're lucky enough to have someone around while that happens. And buddy systems are always best practice, but there's a lot of environments where that's not happening. And so 10 to 40 milliamps is really all it takes to cause I would consider life-threatening scenario.
Absolutely.
Because if you're locked on and no one's around to get you off, what's going to happen, right? The longer you're locked onto a circuit, the longer you're exposed to this hazard, the worse it is. You know, respiratory paralysis, kind of hard to live whenever you can't breathe. Okay. Ventricular fibrillations, your heart's beating out of rhythm. So even at that point, if you don't get medical attention and get that fixed, then it could end up killing you later on. Obviously, your heart stopping beating altogether. Just an amp and a half going through you. That's it. An amp and a half and above. Your tissues and organs will actually start to burn. Okay. That means that you're cooking from the inside out. All right. So it does not take very much to cause a lot of damage. So to kind of summarize the electric shock hazard, what we're going to be talking about is anything for 50 volts and greater. If it's 50 volts and greater, you got to be qualified. You got to be able to know your boundaries and your PPE and all that stuff to make sure that you are protected from it, because that can and has killed people before. Okay. What about arc flash?
Why do we need these boundaries, right? You know, it's because of arc flash and what happens and how they, you know, they actually blow out of the equipment. Okay.
Sure.
You drop take this instance, you know, you drop a three-phase, or an uninsulated tool, for instance, across three-phase conductors. Well, you're gonna have blinding light, molten copper, pressure and sound waves, copper vapor, shrapnel. Okay, that's all blowing out of the equipment. Okay,
Right.
so without these boundaries in place and wearing the proper PPE, now these are all life-threatening injuries to yourself, people walking by, people who have no business even being around the equipment.
Right.
You know, they all causes injury.
Right. And you don't have to be servicing or maintaining equipment for this to happen. Just leaving stuff in or on top of enclosures, you know, if it's on top and there's an open knockout, it could fall in. If it's in the enclosure, it could shift in cross phases at any point. Poor workmanship, you know, maybe you turned it off to do your maintenance, but then you didn't do it right. And then you go to turn it on. Well, that could be the instigator, right? Antiquated or improperly maintained equipment, that can blow up all on its own. You don't even have to be working on it. You don't have to have open. You don't have to be, you know, changing its state. If it has an internal failure, it's not maintained properly, maybe not even rated for the system anymore because there's more available fault current than whenever it was originally installed. You could have something scorching up and blowing off the doors, blowing holes up the sides, whatever the case may be. And wildlife, you know, that's another common one. Open knockouts, panel covers being left off, or even just a few of those dead front screws being left off enough that it can peek open enough that squirrels or mice or whatever can get in there.
Improper tools and meters.
Yep.
Using the wrong tools, using the wrong meters.
Absolutely.
I always like to say when leaving items in or on top of enclosure, I like to say when I go to open panels, you know, I always like to dust the top of a panel.
Sure.
And I'm not the cleaning crowd. Like people, I'm not there to clean your equipment. I just want to make sure there's no screws or anything loose on top, that when I open that panel off, something's going to fall in, you know, and cause an arc flash while I'm there working.
Right. Even something as simple as conductive dust or just buildup of normal dust over time can cause an arc flash. So there's a lot of things that can go wrong. And so the misconception that, hey, I'm not going to be adjusting or servicing this while it's energized, I don't need to worry about these hazards, is completely false. All right. And if you're not properly protected, well, there's a lot of things that can go wrong, you know, for an arc flash or even a shock, especially those major shock events. You end up needing surgeries oftentimes, if you even make it out of that situation, right? But even an arc flash, you know, whatever isn't protected, it's going to have some pretty severe burn injuries.
Yeah,
right.
Absolutely.
All right, so we want to protect from these, right? And I have a comment here. Carlton says, where it's not labeled, they do lots of hot work, which is not always safe. Like, that's a good point. If you don't have the information you need, how far out the boundaries are, what PPE is required within them, that sort of thing, a lot of people assume, well, then it's no big deal. There's nothing telling me I need to do something special, so I can just get in and do this, which is absolutely wrong, but it happens all the time. So got to make sure that you know what those shock and arc flash hazards are, what the boundaries are, and how to use them, which kind of leads us into this next section here. All right, so obviously we've got several codes and standards that we're trying to follow as far as electric shock and arc flash protection. Okay, install it right, maintain it well, and work around it safely. What we're really focused on here today is that third piece, the NFPA 70E, to make sure that you work around it safely. Okay, so any good workplace that has a strong safety culture, right, should have, and really all workplaces must have, but you know, some people don't get up to speed with this as often as they probably should. There's this thing called an electrical safety program. Okay, so do you have an electrical safety program? And better yet, is it up to date? Okay, so yes, no, not sure. Select your answer and hit submit. This is where you would document what to do with those boundaries and how often to check to see if they need to be updated. You know, if something changes, make sure that you have those labels changed, such and so forth. Who's allowed within those boundaries? What should they be doing? For everyone else, what they need to respect. How are you going to establish the boundaries? You know, train over even those people who have no business getting in and around electrical equipment. At very least, train them to know what it looks like when a boundary is established, so they don't ignore it, right? All this stuff would be documented in a complete and up-to-date electrical safety program. So yes, no, not sure. Give it a few more moments for people to submit their answer here. All right, so majority said yes. Wonderful, you know, update it to the 2024 edition. There have been a few minor changes that could make a difference in how your work practices are applied. But if you reference specific articles and stuff, you know, stuff's moved around, so you gotta update to that. For those of you who said no, you know, that's something that you should be really working towards. You know, maybe you have one, definitely make sure it's up to date. If you don't have one at all, definitely get started, you know, finding a way to write that. That's something that I help with if needed. And for those of you who said not sure, well, ask around. Maybe it's not your role to work on that or update it or anything like that, but you probably should know where it is and what it says. So go figure that out. All right. Because it is the employer's responsibility to essentially have an electrical safety program, establish, document, and implement safety-related work practices and procedures that are required by the NFPA 70E. The other side of it is oftentimes people have the program, but they don't train over it. And so the second piece of it is very important. Provide employees training. You can't expect people to follow practices that you've never told them about, okay? Because the employee responsibility, pretty simple. You know, they comply with the safety related work practices that are based on the 70E that are provided by the employer, okay? Part of that is job safety planning. So whenever we talk about establishing boundaries, job safety planning is key, okay? You have to be able to stop and know when these apply and where they go and what to do within them. All that goes into a job safety plan. So when do we need to do these?
Before the start of each task.
Right. Anytime there's possible exposure to electrical hazards, you should be having people stop and complete a job plan and talk it through with those involved. Okay, so what goes into a job safety plan?
So first, be completed by a qualified person. Okay, so no unqualified person should be completing this because they're not going to be working on the electrical equipment, so they don't know the hazards that they could be facing.
Sure.
Obviously be documented, you know, document everything, write everything down.
If it's not documented, it didn't happen, right?
Absolutely. And include the following information. So a description of the job and the individual task for each person, identification of the electrical hazards with each task, an electric shock and arc flash risk assessment, work procedures involved, special precautions, energy source controls, and their emergency response plan. So if something does go wrong, what's our response plan?
Right. So we don't panic in the moment,
Yes.
right? So the information that has to be included in a job safety plan, where do you get that? All right, so maybe you know what the job is and what the tasks are, the equipment, sure. You can figure that one out, no problem. That's the whole reason why you're about to open this. Identification of the electrical hazards and doing your risk assessments for shock and arc flash, and then what to do to protect yourself from those shock and arc flash hazards, all that stuff comes from a proper analysis, right? A proper analysis and safety program. Without that, you're kind of shooting in the dark. Okay. So thankfully, the electric shock hazards are pretty straightforward. They're based on nominal voltage. You know, what you're doing obviously can change your level of risk, but once you know what that highest voltage is within the enclosure, you'll know what the boundaries are, what to wear within those boundaries. I mean, you just kind of have to look at tables and look in the references. You're good to go. But the the arc flash hazard, the severity of burn potential is more difficult. That's where you have to have that arc flash study performed. Otherwise, again, you're just kind of guessing, and you shouldn't be guessing with people's lives.
And we'll talk about arc flash boundaries, and you can't get that without a study.
Exactly. So what do these boundaries mean? So we've got 3 different ones actually that we're talking about. There's 2 shock and 1 arc flash boundary. So let's talk about the shock boundaries first.
Yeah, limited approach and restricted approach. Okay. Limited approach boundary, 42 inches.
Basically.
Restricted approach, 12 inches.
Right.
Okay.
For low voltage equipment, that's pretty standard rule of thumb there.
So limited approach is an approach limit at a distance from exposed energized electrical conductor or circuit part within which an electric shock hazard exists. Definition from 70E.
Right.
Restricted approach boundary is an approach limit at a distance from an exposed energized electrical conductor or circuit part within which there's an increased likelihood of electric shock due to electrical arc over. That's combined with inadvertent movement.
Right. So there's a lot of things that could cause someone to get involved into an electrical circuit that is above and beyond what you might be thinking of. So using improper tools, obviously you can get shocked from that.
Yes.
But within the limited approach, that 42 inches, that 3.5 feet, it is possible, even at that point, to cause someone to get shocked. Maybe you're walking too close and you stumble into it. Maybe you're walking too close with conductive material and bump it. You swing it around, bump some, whatever it is.
Stick a conduit.
Yeah, whatever. Stuff happens. It goes wrong. Let's just keep people back at least that 3.5 feet. And then the restricted approach boundary, obviously, you're within a foot. Your likelihood of accidentally bumping it, pretty high. All right. So then the other side of it's that electrical arc over. Again, you don't have to touch it for it to hurt you within a certain distance. And then that arc flash boundary.
Yeah, so that's what an arc flash hazard exists, an approach limit from the arc source, which incident equals 1.2 calories per centimeter squared.
Right. So this gets a little more specific.
Yes. And this is the boundary that's determined based off a study. Right. You can't not have a study and have an arc flash boundary. You're not going to know it.
Exactly.
It changes.
One thing to note, and it is an informational note in the 70E as far as this boundary is concerned, the reason they chose 1.2 calories per centimeter squared is based off the Stoll skin burn injury model, which says that the onset of a second-degree burn on unprotected skin is likely to occur at
1.2 calories.
1.2 calories for 1 second.
So does it make you safe if you're on the outside the arc flash boundary?
Not necessarily. Yeah, if you're standing right at that boundary, just barely behind it, you could technically get up to a second-degree burn. Okay.
So even with your boundary set at the arc flash boundary, someone walks past unprotected skin, they have the potential to have second-degree burns.
Right. Exactly. So whenever we talk about establishing the boundaries and what you can do as far as that's concerned, you're gonna have to compare what's the furthest boundary, and if the arc flash boundary is the one that's close to the limited or it's further than, I would take it out another foot or two just to be safe. Okay. But let's dive in. Let's get into a little more specific about what the electric shock and arc flash boundary requirements are per the 70E. So we just looked at the definitions, but I want to know what the 70E actually says about working in and around those boundaries. So if you don't have a copy of the NFPA 70E, make sure you get one. I like to have the physical copy. It's easy to flip through the book and reference things. Otherwise, they also have this really nice NFPA link subscription now that you can sign up for. super easy to navigate. You can get access to all the NFPA codes and standards actually through that, not just 70E. Or you can do what we're going to be doing today, which is just the free access online. You create an account, you go to the standard page, and there should be an option to hit free access. It's a little more cumbersome to work with than an NFPA link, but it gets us by. So let's look at what the 70E says for the electric shock boundaries. So right now I am in Article 130.4 Part E for the 2024 70E. On the right side there, and I'm going to zoom in just a little more to make it easy to read. Whoops. So the electric shock protection boundaries. Basically, you got two different ones. We've already told you, limited and restricted approach. Okay, whenever you've got exposed, energized conductors or circuit parts. And those distances are based on those two tables that it talks about for AC versus DC voltage. Okay, so we'll look at what those tables say in just a moment, but that's really what it is. Know the voltage, and then your limited and restricted approach come from those tables. It does have that note that says the arc flash boundary could be greater. So you got to compare shock versus arc flash whenever you talk about keeping people safe. So that limited approach boundary, what's it say as far as approach by unqualified persons?
So no qualified person is allowed to be inside that limited approach boundary unless they're accompanied by a qualified personnel.
Right. So essentially, they're not supposed to cross the limited approach boundary unless they have somebody who's qualified that can advise and oversee them. Basically, this is giving the exception for whenever someone's in training. That's how I like
That's
to
the
look
only
at
time
this.
it really happens.
Right.
Apprenticeship programs, hands-on training, on-the-job training.
You're not qualified yet. Okay. So difference between qualified versus unqualified personnel being able to get in these boundaries, that's important to know. But if they're not in training, they have no reason to be in there, then they're not going to cross the limited approach boundary, period. End of story. That is the minimum distance that they cannot be within. And whenever you enter the limited approach boundary, you have to be aware of those hazards. You have to have, already been kind of trained on these possible hazards and so on and so forth. Okay.
Your pre-job planning you should go through that as well with the qualified person, so you also know.
Absolutely. Once we get to the restricted approach boundary, it's a no-go zone for unqualified personnel. They are never allowed to cross the restricted approach boundary. Even if you're in training, you have to be qualified to that task before you cross it. All right, so that's a little gray area. It gets a little tricky, right? How do you qualify someone until they've actually done it? But you can qualify someone without the hazard being there and then verify it, after the fact. There's kind of a step-by-step process there, but don't just start letting people get to work and do it. Okay. Now, in the restricted approach boundary, qualified persons still need to be very careful, right? Even though they're qualified doesn't make them invincible. Okay. So no conductive objects are allowed within the restricted approach boundary. What kind of conductive objects might that be?
Rings.
Yeah.
Necklaces. Watches, phones, keys. Conductive items that are on your personnel that don't need to be on. You know, uninsulated tools, improper tools.
Absolutely.
Using those.
Absolutely. So
metal frame glasses. I could keep going. Moving on.
Exactly. Nothing that makes it easier for that electrical arc over, basically. Nothing that'll help the current leave its intended pathway. And this again is for 50 volts or more. Okay, so don't get within that restricted approach. 50 volts or greater with anything conductive. And you must be wearing insulated gloves or maybe even sleeves to protect against those energized parts, depending on what you're doing. Okay, so that is what's required at a minimum for the limited and restricted approach boundary. And then we can go to the next page and it's got the tables that tell you what they are. Okay, so we kind of already mentioned it. Good rule of thumb to keep in mind, kind of simplifying. If you have low voltage equipment, 750 volts or less, we're looking at least in this table for AC, we're looking at a 3.5 foot limited approach for fixed parts, and then a foot restricted approach. Technically 150 volts and less, the restricted approach just says avoid contact. All right, I do understand that a lot of people just use that. However, what does that mean?
Don't ever touch it.
How do you know whenever you cross that, right? Let's just protect ourselves, okay? I like to just give the rule of thumb, if it's 750 volts or below, let's just keep it a 1 foot restricted approach boundary so that it's easy for everybody to know, hey, I'm within a foot. It's reasonable that I might accidentally touch this. Okay. That's just a policy that you can go above and beyond the minimum requirements. And then you can look at the DC table as well, which is just below that. It's kind of the same up to 1,000 volts. It's got the same distances. And if you do have medium voltage equipment, just make sure that you're looking for movable versus fixed. You know, most of the time the movable stuff ends up in like overhead lines or stuff like that. Maybe you have other things that are considered movable. You can get into all that as well. But 3.5, 1 foot.
Yep.
Those are the two main shock boundaries that you have to think about unless you have medium voltage stuff. Okay. Now, what about the arc flash boundary? Let's see. I'm going to skip over to page 32. And there's the arc flash boundary section. So we're looking at Article 130.5, Part E now. The arc flash boundary. Again, it says that it's where 1.2 calories per centimeter squared. That's where it's calculated to. Okay. And then how do you determine that? Is through a study.
Yep.
And once you're within those boundaries, you have to have the arc rated PPE. Okay. To the extent of the hazard. All right. So that's it. Have the arc rated PPE to the extent of the hazard within whatever the arc flash boundary ends up being after the study's completed. Okay. So it really is reliant on that study. It's not like the shock hazard where you can just look at a table and move on. All right, so let's get back to this slide deck here and look at what a warning label might entail.
Yeah, so we got an example of an arc flash label here. There's one of our labels. You don't have one of our labels, should still have the same information that we're going to describe. It just may look different or be in a different place in the label.
Absolutely.
All right, so the first thing we're going to find on the label is the arc flash boundary. Okay. So this arc flash boundary for this label is 57 inches. Right, shown in the orange there. That's at 7.84 calories. For this example, arc flash boundary 57 inches.
Right, so that changes from piece of equipment to piece of equipment. Depending on the results of the study, the arc flash boundary fluctuates.
Correct. And then in our shock box that we call it, the bottom left corner, okay, we have our shock boundaries. Once again, limited approach boundary 42 inches and restricted approach boundary of 12 inches. And those are going to be the same for anything low voltage.
Right, right. So again, if you have the arc flash warning label, you don't technically have to have a separate labeling system for your shock hazards. You know, maybe it's nice to have that big 480 right on the top so that nobody misses that fact, but it's on this label. If people know how to read through them, which qualified personnel should, then you don't have to have a separate labeling method. There's a whole bunch more information on this label. You know, we've got other videos and times that we've gone through all this detail. But really, again, what we're focusing on are those boundaries. So in this example, you know, we've been saying we have to compare. So in this example, what would be the hazard boundary that we should focus on?
The arc flash boundary?
Yeah. So it's 42-inch limited approach. You know, that's always going to be the minimum boundary. Arc flash boundary happens to be greater than that. So walk it out that far, add another foot or two, help keep people from those second-degree burns, okay? Within that arc flash boundary, whatever that arc flash boundary ends up being, you need to have the right protective equipment on. Okay. So let's talk through some of those examples.
Yeah, so we have our site-specific levels, but we'll start the level dash. Okay, for us, that's anything less than 1.2 calories per centimeter squared.
Right.
Safety glasses, hearing protection. Right, that's a part of our PP at all times. Anytime we're inside that arc flash boundary, hearing protection and eyewear. Arc rated shirt and pants. Okay, they are insulated rubber gloves, leather protectors, and then the leather uppers and rubber soles, and proper shoes. Yeah.
So we have technically created this level because a couple editions ago, they removed the guidance on what to do if it's less than 1.2 cals in the 70E. But looking at videos and hearing stories, we still recommend arc rated clothing to help keep from ignition from molten material flinging out. Okay, so like if you're wearing 100% cotton long sleeve tee, you know, they're going to be pretty thin. Looks like maybe we had a connection issue for a second there. I'm going to apologize. I don't know what's going on, but I'm going to stop the webcam just to be sure that this doesn't crash on us. Sorry about that, guys. So we still recommend arc rated shirt and pants to make sure, again, that that cotton doesn't ignite from molten material flinging out, okay? The rubber gloves and leather protectors, that's for the shock hazard, right? So within the arc flash boundary, or if you're getting that close, you're already crossing the restricted approach boundary. In this example, you know, being 9 inches, right? If you get close enough, you should have your shock protection on. Insulated gloves, leather protectors.
Same with your footwear, shock protection.
Right.
Yeah, your footwear, the leather uppers and rubber soles, those aren't your EH rated boots. Those aren't there for arc flash protection. They're there for your electric shock protection.
Right.
Keep you from becoming the ground.
The leather uppers,
step potential.
Right. The leather uppers can protect the tops of your feet from getting burnt, but the main goal is that shock protection, as Trey mentioned.
I think it's important to note as we're going to go through these different levels, you know, of examples. We're about to do level 1 and level 2 next. These are all recommended minimum PPE.
Yep, that's a good point.
You know, your risk assessment could determine that, you know, although it is in this case 0.36 calories, you may have to wear a level 2 suit because of your risk assessment. You know, it's deemed more hazardous than what, you know, the study was done at.
Right.
Level 1, level 2, different levels, but they have the same recommended minimum PPE. Okay, so once again, safety glasses, hearing protection, part of our PPE at all times inside the arc flash boundary. Hard hat face shield, the balaclava combo. Right, if you don't have that, you can use the arc flash suit hood. The arc rated shirt and pants with a minimum rating of 8 calories per centimeter squared. Insulated rubber gloves and leather protectors, and then your leather uppers and rubber soles.
Maybe you still have an arc rated uniform on, and so you don't need the coverall that's pictured here, separate shirt and pants, or you don't use arc rated uniforms. Coverall would be a good option there, as long as, you know, the uniforms aren't synthetic fibers. Okay, so yes, still have your shock protection. Definitely want to have that on anytime you're within those shock boundaries. And then the arc flash boundary, we've got this additional PPE.
3 and 4, different levels, same recommended minimum PPE.
Right.
Safety glass hearing protection, you know what I say?
Still there. Yep.
Still there, hasn't gone away. Hey, the arc flash beekeeper style hood, the 40 cal suit hood is a more common one now. They got the flip up visors rather than the suit hood. Whatever you have, 40 calorie rated at minimum. Arc rated jacket and pants, minimum rating of 40 calories per centimeter squared. Shock protection is still there. Insulated rubber gloves, leather protectors, and then your leather uppers and rubber soles.
It is important to note that in the 2024 version of the 70E, leather protectors are not the only kind of protector gloves that are available now. They do make arc rated ones. Vast majority of people still just have leather protectors though. Okay. So if you're already upgrading and you're getting the fancier newfangled arc rated protector gloves that have been approved to put over rubber gloves, fantastic, good for you. That is absolutely acceptable as well.
Yes, 2024 just says protector gloves.
Right.
So we're
making the point there. Now, here's a unique situation. If you have arc flash hazards calculated greater than what PPE you have available, then we're going to change it to a danger label. Oftentimes the cutoff being 40 cals. Most of our clients they have a 40 cal suit, you know, maybe, and that's where it cuts off. Sometimes they have greater than that, and they've created a certain policy that allows up to, you know, 60 cals or whatever. Fine. Wherever that cutoff is where we're going to switch to a danger, so that it says no PPE defined. In other words, you got to think about this differently and or contract it out to somebody who has the appropriate PPE to handle these hazards. Another thing is, as the PPE levels went up, you should have noticed that the arc flash boundary also went up. Okay, so the more PPE you need, the further out the boundaries end up going, which make it even more important to truly block off your work area. Nobody should be stumbling within those boundaries at all. So where do you find these labels so that you know what information to pull from?
Panel boards, disconnects, right on the front.
Yep.
Eye level, walk up to, you can't miss it. So for those of you that said you don't know if you have labels on your equipment, like Caitlyn mentioned, just go all out. Next time you're strolling through the facility, take a look. They should be front and obvious. And if they're not there, then you probably don't have them.
Right. Well, and even in these pictures, there's other labels that say danger, and it shows some electric, like basic hazard information. You know, hey, this could hurt or kill you. You should follow 70E requirements. That's not what we're talking about.
Yeah, those are the manufacturer shock labels.
Yeah.
That don't have boundaries. Yes, there's a shock hazard present, but you know, if it doesn't have the right information that our labels,
there's no specifics.
Example showed, correct.
Yeah, if there's no specifics, that doesn't count. Okay. If it's just a general warning, that doesn't count. You need to know how severe the hazards are and how far up the boundaries go so that you can protect yourself accordingly.
Switchboards, you'll have a label for the main, and they have a label for each section following.
Right. Switchboard, switchgear, any equipment that has this kind of setup.
Yep.
Right.
MCCs, okay, they're going to be you have a label for each section, whether you're going to see it on the wire run trays here, you're going to see them at the top of each section of MCC. It's going to be the same level or same label, excuse me, across each section. Okay, same bus run down the back, same potential for each bucket.
Right. Right.
Overhead bus duct, we like to make our labels a little larger. All right, so 8.5 by 11, fold in half, clear sheet, they hang from the bus duct. You can't miss them. Our goal with this is you can be on the ground. I can look up. I can, in this case, see a giant level 2. I know I need to put on a minimum of level 2 PP.
Right.
Okay, and we place them every 30 foot. The goal with that, you can look left, you can look right. You're going to see an arc flash label. You cannot miss it.
Right. And as you get used to seeing these labels and knowing the boundaries and knowing what level of PPE and the type of distances you see with those levels of PPE as far as the arc flash boundary is concerned, that gives you a lot of information before you get up there. You know, you can be a little conservative and barricade out or block out your work area further than what a typical level 2 requires, just to be safe. That way you don't have to come back down and do it once you look at the specific number. Well, still look at it, right?
Yeah.
Just in case you actually underdid it. So with this information, the types of things to do to keep people out. All right, so we talked about how to identify the hazards and how to be protected within those boundaries. How do you keep other people out of those boundaries? All right, so I'm gonna try to turn this back on because we're gonna show you a couple things, but really we're looking at barricades and attendants. So what does the 70E say about barricades and attendants?
Yeah, first I think we should look at our label.
Absolutely.
And we want to see between our arc flash boundary and limited approach boundary, what is the greatest distance? Because that's where we're going to set up our boundary between the arc flash and limited approach. More than likely, it's going to be your arc flash boundary on most cases, but you want to look at it, figure out what it is. And then you want to set up a barricade. Okay, so barricades shall be used in conjunction with safety signs where it's necessary to prevent or limit employee access to work areas containing energized conductors or circuit parts. Okay, so we're setting up a barricade, a barrier, some sort of warning sign to keep people out of our greatest distance that the label shows. So whether it's your arc flash or limited approach boundary.
Right.
Attendants can be used. So if signs or barricades do not provide sufficient warning and protection from electrical hazards, an attendant shall be stationed to warn and protect employees. Sometimes you use both.
Yeah.
Barricades and attendants at the same time, buddy systems. You're working together as a team, you know, to keep people out of that boundary.
I've actually been on sites and it seems crazy to me, but it happens where someone sets up their, you know, tape and cones like we see behind us. Hopefully you can see that. And they're getting ready to work and people get annoyed and they pick the cone up and move it out of their way and walk right through the boundary. And I'm like, what are you doing? Why are you doing this? They just don't understand. They don't respect it.
People see danger tape like we've got here, and it's a sign to go and look at what they got.
They get curious.
They get curious, and then that's where, you know, they see it's danger, and then they want to get closer because they really want to see what's happening on the other side. And that's where you need that attendant to help.
Right. So whatever you use to set up your proper boundaries, make sure it's something obvious that it shouldn't be crossed. You know, I see a lot of people use caution tape. That's better than nothing, but caution is so overused. And also caution doesn't really indicate the level of hazard that electrical is facing. It really should be danger per ANSI standards with the red, or at very least an orange tape with warning, I suppose. I don't see that very often though. So you could use expandable barricades. You could use those A-frame style ones. They make these cones that have the attachment to where it's got extending and retracting tape. That's pretty cool. Signs, again, make sure people understand, hey, this isn't up just to get in your way, right? There's an actual hazard present. So the picture on the right shows that. And things like, you know, walkways. Sometimes it's better just to block it off altogether.
Yeah. If you can, especially, you know, high traffic areas like we have here, you know, hallways, tons of people moving around. I see all the time in hospitals, you know, it's high, you got to shut it down. Although it's inconvenient to some people, there's a reason behind it.
Mhm.
And, you know, people may have to take the long way around, but there's a reason behind it. We don't want people getting that close, you know, because you have to block off the entire hallway, you know, because of the space provided, given.
Right. So want to make sure qualified personnel, they look at the labels, they or at least know what the hazards are, right? How far out's that limited? Look at the boundary for the arc flash, compare the two. Whichever's greater, that's where the barricades should be set up. That's where an attendant should be stationed to keep people safe from walking within those spaces. Okay, and that's anytime it's exposed. So let's see what you guys think. I've got another poll for you. When do qualified persons need to establish the boundaries? Okay, when the work procedure instructs them to, when performing energized work, such as servicing and maintenance, only for tasks and equipment deemed to be quote unquote high risk. You know, you do your risk assessments and it's determined high risk, so set it up then, or before opening electrical equipment and or exposing circuit parts. Okay, when should those boundaries be established? Using barricades, using your attendants, or both? And we have a question here. Is there another way essentially to figure out what PPE to wear other than voltage and energy calculations? Not really. That's the only acceptable method to determine what PPE is required within those boundaries. Also to figure out what those boundaries are is to know the nominal voltage and have some kind of arc flash analysis performed. So it could be, you know, per the 70E, there's two methods that have been recognized. The IEEE 1584 calculation method of finding the incident energy. There's also a tables method in here. It still requires you to know a lot of information to apply it properly though. I see a lot of people misuse the tables method. And honestly, if you have all that information, just plug it into the program and hit calculate and you get your incident energy. The more complete study, more complete analysis. And I think the question is what code sets the boundaries, possibly. So obviously arc flash study, that's going to give you the results of it through the IEEE 1584, and the 70E has determined where that cutoff is. And then OSHA and 70E for the shock boundaries are consistent as far as how far out those hazards are considered present. All right, so I've given some time for people to respond, and most of you got it. I would say there is a correct answer here. Before opening electrical equipment and exposing circuit parts. Okay, if there's a hazard, and remember, shock protection starts as low as 50 volts. So 50 volts and above, I would argue you should be setting up your boundaries. Okay, that limited approach still applies. So got to set up at least that or the arc flash boundary. Okay. Now, what does exposed mean? When do these boundaries really fit? What does that mean? Okay, so exposed is really what we're looking at.
Yeah. So when do we need PPE is kind of what this slide's talking about, when we're exposed versus when we're not. Okay, so if there could be exposed conductor circuit parts, then boundaries must be established to avoid others accidentally crossing into hazardous areas, and appropriate electrical PPE is a must while within the boundaries.
Right.
And then all this should be identified and documented in the job safety plan.
Right.
If there's no exposed conductor circuit parts and you still want to perform a risk assessment, that'll determine if it's safe to interact with the equipment without PPE, but PPE and establishing the boundaries still may still be determined necessary depending on the situation.
Right. So a common one that I see people starting to apply the PPE and boundaries is simply change of state for those, knife style disconnect switches. Mm-hmm. The only thing that's holding that door in place is a little tab. Okay. Maybe an interlock if it's, nice and it's supposed to have that, right? Mm-hmm. But that's it. Just a couple little pieces of metal. In an arc flash scenario, if the change of state is what causes that to flash, that pressure buildup could cause the door to open. And so you're within the boundaries, even though you didn't open the door already necessarily. So it's becoming common practice to wear PPE even for that and to keep people back even for that. Okay, so it really does. It just depends. Another scenario would be if your equipment looks like it's about to fall apart. And you're trying, okay, let's say on the safety side, you're trying to take it out of service. You realize it's a problem and you need to take it out of service. Even just shutting it down could be the problem. Yep. So let's keep people out. Okay. Stuff like that. What actually constitutes as exposed though?
Can you see it?
Basically.
Can you see the metal parts? As it says, if electrical conductors, so wires, bus bars, lugs, taps,
Yep.
etc., then you're more than likely exposed to electrical components.
Right.
Right. I like to mention open knockouts. To me, in a way, you're exposed to that still.
Sure.
Although you can't readily see the lugs, you'd have to maybe look on top of the disconnect or look underneath it, decide wherever the open knockout is, you can still see it, you're exposed. You have that
Right.
potential for something to easily fall in there and an arc flash hazard happen.
Right. So the exposed part is like capable of being touched or approached nearer than a safe distance. That is more specific to the shock hazard. Whenever we're talking about arc flash hazard, even if you can't touch it, like you reach your hand in that or your fingers in that little knockout and you can't touch anything, great. All right, fine. But you could still have that energy blowout from an arc flash. Another example would be those touch safe plastic guards that they have. I've heard crazy stories where yeah, sure. You put your hand on it, you're probably not going to touch anything. Don't be doing that willy-nilly just to test it. But you're not supposed to be able to touch anything and get shocked. But there is still enough of an opening that something could fall in and cross phases and cause that arc flash. Little piece of plastic ain't gonna stop that.
Nope.
Same thing with those plexiglass covers. Even breaker blinks.
Arc flash hazards of how hot?
Exactly.
Tens of thousands.
Exactly.
They're gonna melt that little plastic real fast.
Right. Okay, a panel board. You've got a few breakers and then you've filled in those little plastic tabs for the breaker blinks so that you don't accidentally touch, stuff's not accidentally falling in. Great. Still, if there's an arc flash, what's going to happen with those little plastic tabs?
Yeah, they're melting. They're getting blown off.
Out. Yeah. So what is exposed here? Right? Got to make sure. And another thing, just because you shut off the disconnect for what's feeding your equipment doesn't mean you can get away from these PPE and boundary requirements. Okay? Because all electrical conductors or circuit parts shall be considered energized until verified to be de-energized through the process of achieving an electrically safe work condition. Okay, and to do that, it's an 8-step process. Kind of just summarized it on this slide here.
You want to determine all source of electricity?
Yep.
Okay, more than sometimes you got more than one source. You want to make sure you got all of them determined. You know all of them. Open all disconnecting means. Visually verify.
If possible.
Yeah, when possible. We see disconnects where one of the knife blades will, it's self-welded shut, so two of them will open. Release stored electrical energy, release or block stored mechanical energy, lockout tagout with the proper lockout tagout program.
Right.
Triple test, use your live dead live test with the proper meter. Check all sources at all points of work at the change in the 2024.
Right. Where are you going to stick your hands?
Yep.
Make sure it's dead there and make sure your meter's actually working. Don't trust that 0 is actually 0. Got to verify it. Okay.
And then number 8, the last step was ground if you determine necessary.
Yeah, temporary grounds.
Yep.
Okay. So until you can complete these steps, boundaries and PPE are still required to be established and utilized. Okay. So again, you're shutting it off, you're making it a safe work condition. People still can't approach during this process. You still got to be protected during this process. The other side of it is, okay, let's say the times that you actually do have to perform energized work. And I'm just going to make a real quick note here. It should be infeasible to do de-energized, not inconvenient. Yeah. Not inconvenient. A lot of times people are using improper justification to do energized work. And I'm helping them, rewrite their program, and they've got a list of things that specifically happen all the time, and they're like, hey, we can't shut it off for this, this, and this. And I'm like, why? Yeah. And they give me all sorts of reasons. I'm like, that sounds pretty inconvenient. You're right. But it's not infeasible. So per the codes and standards, if you put this in your safety program, you're violating the codes and standards. Okay, this is not allowed. They're like, well, shoot, But if you do actually have that justification, and sometimes you do, if you cross the restricted approach boundary, you need to actually have a permit to do this work. Okay, and then it also leaves it open for permitting if you cross the restricted approach boundary to work. I'm sorry, if you don't cross the restricted approach boundary, just in case there's some other reason this might be considered hazardous. There's an increased likelihood of injury. There is still a potential of an arc flash hazard, even though you're not reaching within the restricted approach boundary. It leaves it up to the employer or the worker to decide, yeah, I need a second person. I need someone to sign off and justify to leave this energized. Okay. You can do testing, troubleshooting, and voltage measuring without the permit though. Okay. So as long as you're just using the meter, not actually going to service or adjust anything. You still have to have your job safety plan, still got to set up your boundary, still got to wear the right PPE, but you don't technically have to have the permit to cross the restricted approach boundary at that point. Okay, so let's summarize. We're getting close to the end of the hour here. Let's summarize the electrical hazard boundaries and the generic steps ahead. So first up, plan ahead.
Yeah.
Right? You approach equipment, what should you be doing?
Yeah, he's reading over the label, seeing what PPE he needs, seeing what boundaries he's gonna have to set up. He's filling out his job safety plan. He's getting ready to start work.
Right. He's doing the risk assessments. He's thinking about what he's doing, how he's going to do it, and, you know, what the environment is. All those things, once again, get documented in the job safety plan before anything happens. Okay. Then go ahead and set up those boundaries.
Yeah, so step one, you know, he got the boundaries, he's establishing them. Okay, so now he knows the distance he needs. And this is a good example here in these videos, Caitlyn. You don't always have safety cones, traffic cones,
Right. Barriers, yeah.
A-frames. Here, they're just using pillars in the building, you know, to set up whatever they can use to keep people out. They work just the same.
Those boundaries are a minimum, right?
Yeah.
And then if you're going to be in those boundaries, you got to make sure you have the right PPE. Okay, so don whatever is needed prior to entering and opening up that equipment. Okay, so putting on the suits, you know, making sure you got those bibs on or our graded uniforms or coveralls, whatever you've got, safety glasses, hearing protection, and maybe you got the full 40 cal suit jacket as well. Certainly your gloves, you're really not going to get away from those either. Okay, your rubber gloves with the protectors over the top of them, making sure you inspect and you know, make sure everything's in good condition and all that as well before
field testing your gloves before putting them on.
All right, so you got your boundaries established, you got your PPE on, then you can try to get to work, right? And in this example, all he's really doing is verifying absence of voltage, but you see he's got the PPE, he set up his boundaries, people cannot approach closer than a safe distance just to verify that it is in fact dead before he does his servicing or maintenance or whatever he needs to do.
And once he verified the absence of voltage,
he could have taken away that boundary.
He can take his PPE off.
Right.
They got a buddy system working together.
Right.
You know, if something was to happen, you got the buddy system there to help.
Yeah. They would stay outside of that boundary wherever you've taped it up, just to make sure that others stay away as well. And
can we go back to that?
Also,
can we watch that last part just one more time?
Yeah.
With
let's see. This part?
Yeah. I think it's just a good example too with the limited approach boundary. You could use an example where you have that unqualified person who's in the boundary, and I know they're not quite in that 42 inches, but you know, they're only there, they're suited up, they're there for training, they're learning from their journeyman or whoever it may be. You know, that's a good example of on-the-job training.
Right. There's a lot of ways we could use that information. Okay. So those are the overly simplified steps, right? Don't just use that, but there's a lot more to it. But that's kind of how it boils down to. So how do you get started with this? What do you do to establish these boundaries in your workplace? Well, the first thing is just make sure there's a complete and accurate system study performed. It's got to be, you know, a licensed engineer. Most states require that because it is an engineering service. So you got to have someone licensed to sign off on it. This identifies arc flash and shock hazards so that you know how far out the boundaries are, what the severity is, what to wear within those boundaries, all those wonderful things that you have to do for safety.
Yep.
And then provide those barricade methods. Okay, oftentimes I see the studies done and people are trained over, you know, keep people out of this and wear it within, but you don't have a way to keep people out of that. And you don't have enough people on staff to do a buddy system all the time.
Buy roll tape.
Yeah, it's really not that hard.
Yeah, roll tape, you know, or if you know, and the opposite, if you do have people on staff and you don't have time to buy tape, find somebody to work a buddy system who can keep people out. You know, that buddy stays out of the arc flash boundary. Have that attendant keep them out. It's simple as that until you can purchase giant cones like we have here, the A-frame protectors, barriers that, you know, we see in the training slides.
Right. Or both if you need both.
Yeah.
And certainly update your safety program and retrain personnel if any of this is prompting you to change how you think about the use of boundaries, right? If people have been taught, hey, I had some people answer the question that, you know, if you do energized work, you set up boundaries. That's great, but it's more than just those energized servicing or maintenance tasks that require this. So maybe it's time to update your safety program if it doesn't cover those, and then retrain those personnel to make sure that proper policies and practices are being followed, right? How to establish these boundaries, what to do when crossing them, job safety plans, risk assessments, all those wonderful things that you have to think about. And certainly, if you need help, we can always get you covered.
Oh yeah.
Right. We have a lot of service offerings as well as custom solutions. You know, if you have a question and it's related to electrical safety or lockout tagout, we can probably help you.
But I think the big one, arc flash studies.
Right.
You know, especially with the boundaries. That's what today was about, was boundaries and barricades, arc flash studies.
And then the training.
And trainings.
The studies and training. Have the labels and know what to do with them.
Yep.
Okay. All right. So we've covered lots of information today, got a crash course into those boundaries and what to do within them. If you have questions, please feel free to submit them in the question feature now. We had some people interacting throughout the webinar, but this would be the perfect time to do so. Otherwise, we understand that it is actually right on the dot, 11 a.m. Central. So it is technically the end of this webinar time. Thank you for your attendance, and I hope that this was informative and helpful.
Yeah.
If you do have any questions and you don't have time to stick around and type it out now, you can always email us. You know, it's on the screen there, or call the office. Just go to our website. Somehow, some way, you'll find a way to contact us. Okay. So thank you so much. And we will open it up to questions now. Otherwise, have a great one.